and welcome to tonight's space sleep story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we embark on the final weeks of humanity's first journey to Mars. 220 days into a 259-day voyage, Mars is no longer a distant point of light. It's becoming a world. So settle into your most comfortable position, close your eyes, and prepare for arrival at the red planet. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts, filling your lungs completely. 1, 2, 3, 4. Hold the peace within you. Now exhale slowly for 6 counts, releasing all tension. 1, 2, 3, 4, 5, 6. Feel your body releasing into stillness, preparing for tonight's journey. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls with each breath. Breathing in, you draw in calm and peace. Breathing out, you release the day's concerns, the worries, the tension. Let my voice be your guide through tonight's story. With each breath, you release a little more into relaxation, drifting toward sleep as we drift toward Mars. Over the next 75 minutes, we'll experience the final 40 days of approach to Mars. We'll witness Mars growing from a disk the size of the Moon to a planet filling the forward view. We'll prepare for the critical Mars orbit insertion burn, 27 minutes of engine firing that must work perfectly. And then, if all goes according to plan, we'll experience humanity's first orbit of another planet. But for now, rest and breathe as the journey continues. Day 220 of the journey. 220 days since we departed Earth's orbit and set course for Mars. In the forward observation windows, Mars has transformed. No longer a reddish star among the constellations, it's now visible as a disk, showing surface features. White polar caps at north and south, dark regions suggesting ancient terrain, and if you look carefully on the clearest days, the massive shadow of Olympus Mons, the solar system's tallest volcano, casting its presence across the horizon. Olympus Mons rises 21.9 kilometers above the surrounding plains. 2.5 times taller than Mount Everest, its base stretches 600 kilometers across, roughly the distance from San Francisco to Los Angeles. From this distance, 10 million kilometers from Mars, it appears as a dark spot on the Tharsis Plateau. But with each passing day, it grows more distinct, more real. Ancient volcanic features that have been extinct for hundreds of millions of years, waiting patiently for us to arrive. "39 days remain until Mars orbit insertion. 39 days until the most critical maneuver of the entire journey. The spacecraft that has been our home for over 7 months will need to slow down by 2.1 kilometers per second. If the burn is too short, we'll sail past Mars into solar orbit, unable to return. If it's too long, we could crash into the atmosphere. But the mathematics are precise, the planning meticulous. Patient preparation removes all uncertainty. Let's watch Mars grow day by day. On day 220, Mars has an angular size of approximately 2 arc-minutes, about 1/15 the diameter of the Moon as seen from Earth. The polar caps are visible as small white spots at top and bottom of the reddish disk. By day 230, the angular size has grown to 3 arc-minutes. Now we can distinguish bright and dark regions, ancient highlands contrasting with volcanic plains. Mars revealing itself slowly, patiently, as we approach. By day 240, Mars spans 4 arc-minutes across. Individual features are becoming distinct. Olympus Mons is clearly visible now as a dark circular feature on the Tharsis Plateau. The Tharsis region itself, a massive volcanic rise home to 3 other giant volcanoes beside Olympus Mons, dominates the Western Hemisphere. These volcanoes are extinct, dormant for eons, their lava flows frozen in time. We're seeing geology on a scale that makes Earth's features seem small. Day 250 arrives. Mars now spans 6.8 arc-minutes, roughly the same angular size as the Moon appears from Earth. Through the forward windows, it's no longer just a disk, it's becoming a world. Valles Marineris, the Great Canyon system, is visible as a dark scar cutting across the equatorial region. This canyon is 4,000 kilometers long, stretching from New York to Los Angeles if placed on Earth. 200 kilometers wide, 7 kilometers deep in places. The Grand Canyon seems tiny in comparison. The crew spends hours at the observation windows now. Daily photographs document Mars's growth, comparing each day's view to navigation charts prepared on Earth. Measuring features, identifying landmarks, preparing for arrival. After 7 months of looking at stars and empty space, having a destination that shows detail, texture, geography, is psychologically profound. Mars is no longer abstract. It's a place we're going to, a world we'll orbit, a planet we might eventually land on. Real and waiting. On day 225, a small course correction burn occurs. The reaction control thrusters fire for 90 seconds, providing 8 meters per second of delta V. A tiny adjustment by deep space standards, but This burn fine-tunes the approach angle, targeting the precise entry corridor required for Mars orbit insertion. The spacecraft's trajectory is constantly monitored, compared against predictions made months ago. Every measurement confirms we're on path, approaching exactly where we plan to be. The mathematics is working perfectly. Day 245 brings another refinement burn. This one provides 6 meters per second of velocity change, further narrowing the approach corridor. We're targeting an altitude of 125 kilometers above the Martian surface for the MOI burn. The entry corridor is just 10 kilometers wide at that altitude. Miss that corridor, and the burn parameters won't work correctly. But the navigation computer is precise, calculating position and velocity thousands of times per second, confirming constantly that we're on the perfect path. The target orbit is highly elliptical. After the Mars orbit insertion burn, we'll circle Mars in an elongated ellipse. Periapsis, the closest point, will be 300 kilometers above the surface. Apoapsis, the farthest point, will be 35,000 kilometers out. One complete orbit will take 35 hours. This highly elliptical orbit is intentional, providing safety margin and flexibility for future maneuvers. Later, additional burns can circularize the orbit if needed. But first, we must be captured by Mars's gravity. After 220 days of patient travel through empty space, something profound is happening psychologically. The destination is becoming tangible reality. Those orbital mechanics equations calculated so carefully back at Earth, those trajectory plots and delta V budgets, are no longer abstract mathematics. They're steering us toward a precise point in space where we'll fire our engines. The crew feels the shift from traveling to Mars to arriving at Mars. Anticipation building, but controlled and focused. This is what we came for. Mars fills more of the forward window space with each passing day. By day 255, it spans more than 10 arc minutes. Details are sharp and clear now. The northern polar cap, approximately 1,000 kilometers in diameter, shows layered terrain visible even from this distance. The southern cap, smaller at 350 kilometers across, appears more irregular. Both caps are composed of carbon dioxide ice, layered over water ice. In Martian spring and summer, the CO2 sublimates, revealing the water ice beneath. Hellas Planitia is visible now, a massive impact basin in the southern hemisphere, 2,300 kilometers in diameter, 7 kilometers deep at its lowest point. This is the deepest point on Mars. The impact that created Hellas must have been catastrophic billions of years ago, when the solar system was young and violent. Now it's a smooth basin floor, filled with dust deposited over eons. At certain times of Martian year, morning frost forms in Hellas, making the basin floor appear bright white from orbit. Ancient violence giving way to quiet beauty. The spacecraft continues its patient approach. Each day Mars grows larger, more detailed, more real. Each day the crew prepares more thoroughly for what's coming. Mars orbit insertion isn't just another maneuver. It's the culmination of 259 days of travel, years of planning, decades of dreaming. Everything has led to this moment, this arrival. But arrival requires patience, preparation, and perfect execution. We're ready. Mars is waiting. Day 256 arrives. We're approximately 577,000 kilometers from Mars. This distance is significant. We've just entered Mars's sphere of influence. Inside this invisible boundary, Mars's gravity dominates over the Sun's gravitational pull. We're now in Martian space. The planet is our gravitational reference. The sphere of influence is a mathematical concept. It defines the region where a planet's gravity is the primary force on an orbiting object. For Mars, with its relatively small mass, the sphere extends 577,000 kilometers. Crossing this boundary marks entering Mars's domain. We orbit Mars now, not the Sun. 48 to 72 hours remain until Mars orbit insertion. The navigation computer has shifted its calculations from heliocentric to areocentric orbits. Communication delay with Earth is 12 minutes one way. 24-minute round trip for any conversation. During critical burns, we're on our own. Day 257. Mars fills the forward windows completely. Through powerful cameras, surface features are now extraordinarily detailed. Dust storms forming on the horizon, thin atmospheric haze at the limb. Mars showing weather, geography, the subtle activity of a living world. The polar caps show distinct layering. The northern cap displays spiral patterns carved by seasonal sublimation. Scientists believe these layers record climate cycles going back hundreds of thousands of Martian years. Each layer a chapter in atmospheric history, waiting to be read. Through powerful cameras, Phobos is now visible as more than a point of light. Mars's larger moon, 22 kilometers long, orbits just 5,989 kilometers above the surface. Phobos completes an orbit every 7.65 hours. Faster than Mars rotates, it rises in the west and sets in the east. Deimos, the smaller moon, orbits 20,068 kilometers above Mars. 12.6 kilometers long, it takes 30.35 hours to complete one orbit. This is slower than Mars's rotation, so Deimos rises in the east like Earth's moon. Both moons are probably captured asteroids, irregular and dark. Both moons are irregular, potato-shaped bodies with heavily cratered surfaces. They're likely captured asteroids from the nearby asteroid belt. During our orbital phase, we'll pass between Phobos and the Martian surface, tiny eclipses crossing below us. Ancient companions to Mars, waiting patiently. Day 258, the final day before Mars orbit insertion. The crew gathers for comprehensive burn briefing. Mission Control has transmitted final confirmation of burn parameters after analyzing latest trajectory data. Everything checked, verified, confirmed ready for tomorrow's critical maneuver. The waiting is almost over. The burn will last 27 minutes of continuous engine firing. 27 minutes that must be executed with absolute precision. Our current approach velocity is 5.5 kilometers per second relative to Mars. The burn must reduce this by 2.1 kilometers per second, bringing us to orbital velocity. From 5.5 kilometers per second down to 3.4 kilometers per second. That final velocity, 3.4 kilometers per second, is the magic number. It's fast enough to avoid falling into Mars's thin atmosphere, slow enough to be captured by Martian gravity. The balance between escape and capture, calculated precisely. The burn must occur at exactly 125 kilometers altitude above the Martian surface, at a precise position in our approach trajectory. The entry corridor is just 10 kilometers wide, too high and the burn parameters won't capture us, too low and we risk atmospheric contact. But navigation confirms we're tracking perfectly through the center. The accuracy requirement is extraordinary. We must achieve the target delta V within 0.1%. That means plus or minus 2 meters per second margin, out of 2,100 meters per second total change. The propulsion system is designed for this precision, tested, calibrated, ready. During the 27-minute burn, the crew will experience gentle but noticeable acceleration. 0.2 to 0.3 g. After 259 days of weightlessness, even this small acceleration will feel significant. Weight returning, pressure against seats, the sensation of being pushed. Not violent, just persistent and steady. There will be a communication blackout during the burn. The high-gain antenna must point away from Earth, aligned with the engine thrust vector. For 10 to 15 minutes, Earth won't receive telemetry. Controllers will wait anxiously, trusting the spacecraft to execute autonomously. Then, when the antenna reorients, confirmation will arrive. 12 minutes later. This is a one-shot capture. There is no opportunity for retry, no second chance. The spacecraft carries insufficient fuel to escape Mars's gravity and attempt another approach. But this isn't a source of anxiety. It's a testament to preparation. Everything has been calculated, verified, rehearsed. Tomorrow's burn will work because it must, and because we've made it certain. Historical context provides confidence. On June 19, 1976, Viking 1 successfully performed Mars orbit insertion. The 1,006 meter per second delta V burn executed flawlessly. The first successful Mars orbit insertion in history. Since then, Mars Reconnaissance Orbiter, Tianwen-1, and others have repeated the achievement. Tomorrow, we join that legacy. But there have been failures too. Mars Climate Orbiter was lost in September 1999. A unit conversion error, mixing metric and imperial measurements, caused incorrect trajectory calculations. The spacecraft entered Mars's atmosphere too low and burned up. That failure taught critical lessons about verification procedures. Lessons we've learned and implemented. Every calculation checked, every unit verified. Systems check begins with propulsion. Fuel tank pressures are nominal, oxidizer levels full. Engine gimbal mechanisms tested and responsive. Backup propulsion systems verified operational. Though we expect perfect primary system performance, redundancy provides assurance. Every component ready, every system green. The engine that will capture us in Mars orbit is ready to fire. Navigation systems report perfect trajectory tracking. The entry corridor, 10 kilometers wide at 125 kilometers altitude, lies ahead. Our current trajectory passes through its center with minimal error. Guidance computer continuously refining position estimates, velocity vectors, predicted arrival parameters. Thousands of calculations per second, confirming we're exactly where we should be. On path, on schedule, ready. Life support systems are configured for burn operations. Backup environmental control activated. Redundant oxygen systems online. Power supplies verified. During the burn, non-essential experiments will be shut down. All available power directed to propulsion, navigation, and life support. The spacecraft focusing entirely on this single critical task. Arrival at Mars. The crew secures the spacecraft interior. All loose items stowed carefully, everything tied down or locked in place. During the burn, that gentle 0.2 g acceleration will give weight to floating objects. Anything loose could drift and interfere with operations. But the cabin is orderly, prepared, every item in its designated place. Professional discipline evident in every detail. Crew briefing covers communication protocols. During the blackout period, real-time contact with Earth is possible. The spacecraft will execute the burn autonomously, following pre-programmed sequences verified by mission control. When telemetry resumes, Earth will learn our status. 12 minutes after the moment we know ourselves. But they trust us, and we trust the systems. Abort procedures are reviewed, though options are extremely limited. If the engine fails to ignite, we'll sail past Mars. If it shuts down early, we might achieve a highly eccentric orbit or escape entirely. There's no realistic rescue scenario at this distance. But the engine won't fail. It's been tested exhaustively, maintained perfectly, designed with massive reliability margins. Tomorrow it will fire, and we will be captured. Looking back toward Earth one final time. Our home planet is now 230 million kilometers away. 1.5 astronomical units across the solar system. Through telescopes, Earth appears as a pale blue dot, barely visible without magnification. The Moon isn't visible at all, too small and close to Earth to resolve. We're further from home than humans have ever been. Communication delay to Earth is 12 to 20 minutes one way, depending on the precise geometry. Right now, about 12 minutes. When mission control transmits "good luck for tomorrow's burn," those radio waves will travel for 12 minutes at light speed before reaching us. By the time we hear their encouragement, the burn might already be underway. We operate on our own timeline now, supported but independent. This is the farthest distance from Earth that humans have traveled. Previous Mars missions were robotic. The Apollo astronauts reached the Moon, 384,000 kilometers from Earth. We're now 600 times farther. The psychological distance matches the physical. Earth is a memory. Mars is reality. Tomorrow completes the transition. Tonight, the last night of Trans-Mars cruise. Tomorrow morning, if all proceeds as planned, we'll wake as Martian satellites. No longer in solar orbit, but captured by Mars, circling the red planet every 35 hours. The journey that began 259 days ago reaches completion tomorrow. But tonight, rest comes easily. Everything is ready. We are ready. Messages from Earth continue arriving, 12 minutes delayed. Mission controllers have reviewed all systems data, confirmed all parameters nominal. Their final transmission tonight is simple. Quote, "You are go for Mars orbit insertion. We'll see you on the other side." End quote. Professional confidence in simple words. Tomorrow, we arrive. The crew settles into sleeping quarters one last time as a solar orbit spacecraft. Tomorrow Tomorrow's wake-up will be different. Tomorrow's wake-up will be different. Tomorrow, the view through sleeping quarter windows won't be stars and distant Mars. It will be Mars below, Mars surrounding us, Mars as our gravitational home. After 8.5 months of travel, transformation from visitor to satellite, from approaching to arrived. Mars' atmospheric pressure at the surface is 610 pascals. Just 0.6% of Earth's sea level pressure. The atmosphere is 95.3% carbon dioxide, 2.7% nitrogen, 1.6% argon. Too thin to breathe, but thick enough to create weather, dust storms, morning frost. Thin enough to see through clearly. Tomorrow we'll observe this delicate atmosphere from above. Tomorrow, after the burn, we'll be in our highly elliptical orbit, 300 kilometers to 35,000 kilometers altitude. At periapsis, we'll move at 4.5 kilometers per second, surface features rushing past. At apoapsis, just 0.6 kilometers per second, entire hemisphere visible in single view. The orbit provides both close detail and grand perspective. Patient observations from varying distances, exactly as planned. Tomorrow, it begins. Day 259 arrives. Mars orbit insertion day. Final systems verification complete. Crew secured in seats. Spacecraft attitude aligned. The engine points retrograde, opposite our direction of travel. When it fires, we'll slow down. Captured by Martian gravity, Mars fills the entire forward view, surface details sharp and clear. T-1 hour to ignition. Mars now subtends more than 20 degrees in field of view, 40 times the Moon's apparent size from Earth. Dust storms visible on the horizon, thin atmospheric haze at the planet's curved edge. Phobos crossing below our trajectory, tiny irregular moon orbiting beneath us. Communication with Earth confirmed one final time. Mission Control's transmission arrives after 12-minute light speed delay. Quote, "You are go for MOI burn," end quote. But by the time we receive this confirmation, the countdown is already well underway. We operate autonomously now, trusting our systems and our preparation. Mars 600 kilometers below, approaching rapidly. T-10 minutes. Engine preheating begins. Combustion chamber warming to operational temperature, preventing thermal shock at ignition. Attitude thrusters fire in tiny pulses, fine-tuning spacecraft orientation to 0.01 degree precision. Every detail matters now. Fuel pressurization reaching operating levels, propellant tanks ready. Navigation computer displays continuously update. Position, velocity, altitude, time to ignition, all confirmed nominal. We're tracking through the center of the 10-kilometer wide entry corridor at 125 kilometers altitude. Exactly where we need to be. The mathematics that brought us 259 days across the solar system is working perfectly. T-minus 5 minutes. Mars surface visible below. Ancient cratered terrain rushing closer at 5.5 kilometers per second. We're moving so fast relative to Mars that we're covering hundreds of kilometers every minute. But soon, the engine will slow us, capturing us into orbit. Everything ready, everyone focused, the moment approaching. T-minus 1 minute. Final automated system checks complete. All parameters green. The crew feels calm anticipation, not anxiety. This burn will work. It must work. And we've made it certain through patient preparation. 30 seconds. 20. 10 seconds to ignition. 5, 4, 3, 2, 1. Engine ignition. After 259 days of weightlessness, gentle pressure returns. 0.2 G pushing the crew back into their seats. Not violent, not dramatic, just steady, reliable thrust. The spacecraft structure transmits a low rumble from the engine firing behind us. Displays show velocity beginning to decrease. 5.5 kilometers per second, now 5.4. The high-gain antenna now points away from Earth, aligned with thrust vector. Communication blackout begins. For the next 10 to 15 minutes, Earth won't receive our telemetry. Mission control waiting anxiously 230 million kilometers away. But we're alone with Mars now, focused on this single, critical task. Patient deceleration. Velocity displays countdown steadily. 5.3 kilometers per second. 5.2. 5 gentle acceleration continues. Persistent pressure after so many months of floating. Strange but reassuring to feel weight again. Engine temperature stable. Fuel consumption nominal. Trajectory tracking perfectly. Mars' surface passes below at 125 kilometers altitude. Valles Marineris visible beneath us, the Great Canyon system stretching to the horizon. But the crew's attention remains on displays and systems, monitoring the burn's progress. 5.0 kilometers per second now. Halfway through the required velocity change, 13 minutes of burn remaining. The spacecraft shakes gently from continuous combustion. Subtle vibration transmitted through the frame. Fuel gauges show steady depletion, precisely calculated amounts being consumed. The burn must continue for exactly 27 minutes, no more, no less. 4.8 kilometers per second. 4.6. Approaching orbital velocity. "17 minutes of burn elapsed. 10 minutes remaining. Velocity now 4.4 kilometers per second. The crew monitors fuel consumption, engine temperature, guidance tracking, all parameters remaining solidly nominal. Mars continues rolling beneath us. Ancient volcanic plains, crater fields, dry river valleys. 4.2 kilometers per second. Patient deceleration continuing exactly as planned. "20 minutes of burn complete. 7 minutes to engine cutoff. Velocity 4.0 kilometers per second. The mathematics bringing us ever closer to that target number, 3.4 kilometers per second, the velocity that balances between escape and capture. 3.8 kilometers per second now. The rumbling continues, steady and reliable. "25 minutes. 2 minutes to cut off. Velocity 3.5 kilometers per second. Approaching target. The guidance computer counts down final seconds, monitoring velocity with extraordinary precision. 3.45 kilometers per second. 3.42. 3.40. Target velocity achieved. Engine shutdown command issued. The rumbling stops. Pressure releases instantly, weightlessness returning. Silence except for ventilation systems humming softly. Displays confirm orbital parameters. Periapsis 300 kilometers, apoapsis 35,000 kilometers, period 35 hours. The computer states simply, "We are in Mars orbit. We have arrived." but Earth doesn't know yet. The high-gain antenna is being reoriented. 12 minutes until our telemetry reaches mission control. They're waiting anxiously for confirmation. Velocity displays confirm orbital capture. 3.4 kilometers per second at periapsis. Mars' gravity holds us now, no longer visiting, but orbiting. 259 days led to this. Fuel reserves show exactly predicted levels. Every kilogram of propellant consumed precisely as calculated. The burn was perfect, within 2 meters per second of target. Textbook orbital insertion. Telemetry transmission begins, data flowing toward Earth at light speed. 12 minutes across the void, waiting for their response, knowing they're celebrating already. The spacecraft coasts now in captured orbit. Mars passing below at 300 kilometers altitude. Surface features incredibly detailed, ancient terrain revealing geological history. We're truly here. Valles Marineris stretches below, 7 kilometers deep, layered canyon walls. Afternoon sunlight illuminates the eastern rim, shadows filling the immense chasm. Breathtaking scale. Ancient river valleys branch across the highlands. Dry for billions of years, but their shapes remain, carved when Mars had flowing water, evidence of wetter past. Crater fields pass beneath, impacts from solar system's violent youth. Some craters show bright rays extending hundreds of kilometers. Others are ancient, softened by eons of dust. communication from Earth arrives. Quote, "Congratulations, you are in Mars orbit. Welcome to Mars." End quote. Simple words carrying profound meaning. We've arrived. The crew allows quiet celebration, relief washing over everyone. Exhausted but triumphant after 8.5 months, tonight we rest as Martian satellites. Now approaching periapsis at 300 kilometers altitude. Moving 4.5 kilometers per second relative to surface. Features rushing past below, hundreds of kilometers covered every minute. This is orbital velocity at closest approach. Olympus Mons caldera passes directly beneath us. 80 kilometers across, nested collapse features visible in afternoon light. The volcano's summit, 22 kilometers above surrounding plains. Frozen lava flows extending down flanks. Individual boulders visible casting long shadows. At 300 kilometers altitude, resolution allows seeing features 10 meters across. Closer to Mars than ISS orbits Earth. Extraordinary detail revealed. The polar ice cap shows distinct layering, spiral patterns carved by seasonal sublimation. Scientists believe these layers record hundreds of thousands of years of climate cycles. Atmospheric history, written in ice. Ancient river valleys branch across the highlands below. Channels carved billions of years ago when Mars had liquid water. Now dry, but their shapes persist, evidence of Mars's wetter past. Wind-blown dust patterns cover crater floors, subtle ripples revealing prevailing wind directions. Mars still has weather, thin atmosphere creating dust storms and seasonal changes, a world not quite dead. Crater rays extend hundreds of kilometers from bright young impacts. Material ejected during collision remains bright against older, darkened terrain. These impacts happened recently in geological terms, perhaps millions of years ago. Tharsis Plateau dominates the Western Hemisphere, massive volcanic rise home to solar system's largest volcanoes. Olympus Mons, Ascraeus Mons, Pavonis Mons, Arsia Mons, all extinct now, dormant for eons. Hellas Planitia Basin passes below, 2,300 kilometers wide, deepest point on Mars, 7 kilometers below surrounding terrain. Ancient impact that must have been catastrophic, now just smooth basin floor. Approaching Mars's terminator, the boundary between day and night. Afternoon shadows lengthening across canyon walls. The first Mars sunset from orbit approaches. Different from Earth's sunset, Mars's thin atmosphere scatters light differently. The Sun appears smaller at Mars' distance, 43% of solar flux compared to Earth. Dimmer, redder sunlight. As sunset approaches, thin atmospheric glow appears at horizon, blue-white instead of red, opposite of Earth. Mars has butterscotch daytime sky due to suspended dust, but sunset creates blue-tinted glow. Atmospheric pressure just 0.6% of Earth's, too thin for dramatic color displays. But beautiful nonetheless, delicate and strange. Phobos rises rapidly across the darkening sky. The moon orbits faster than Mars rotates, crossing visible sky in about 4 hours. 22 kilometers long, irregular and potato-shaped, racing eastward as sun sets westward. Sunset complete, first Mars night from orbit begins. Surface below now dark except for subtle starlight reflection. Occasional dust storm lightning might be visible in storm season, rare but possible. Tonight, darkness and peace. Stars above clearer than from Earth orbit. No light pollution, thin atmosphere barely interfering. Deimos slowly crossing sky, taking 30 hours to complete orbit. visible as bright, slow-moving star. Looking down at darkness, knowing ancient riverbeds lie below, frozen water at poles, perhaps subsurface ice, the possibility that life once existed here, billions of years ago, questions waiting to be answered through patient study. The spacecraft coasts through Apoapsis now, 35,000 kilometers above surface, moving just 0.6 kilometers per second. Entire hemisphere visible below, Mars as complete world in single view. Slow, peaceful arc. Life support systems hum softly, only sound in cabin. Crew resting after successful insertion. Tomorrow begins scientific observations, orbital survey planning. But tonight, simple rest in achieved orbit. One complete orbit takes 35 hours. From periapsis rushing close over surface to apoapsis distant and slow. Circling Mars in elongated ellipse, exactly as planned. Orbital mechanics working perfectly. First Mars sunrise approaches from orbital night. Sun rising over eastern horizon. Light traveling across curved surface. New day. Olympus Mons summit catches first sunlight, 22 kilometers high, towering above terrain, peak illuminated while lowlands remain in darkness, light spreading downward. Oblique morning light illuminates canyon systems beautifully, shadows filling deep valleys, eastern walls catching bright sun. Geological layers clearly revealed. Extraordinary detail. Shadow Terminator sweeps steadily westward as Mars rotates beneath our orbit. Day advancing across surface, planetary rhythm continuing ancient and patient. Mars turning. We are no longer traveling to Mars. We are of Mars now. Satellite status after 259 days. Coasting through Apoapsis now, 35,000 kilometers above Mars. Entire hemisphere visible below, curving away beautifully. Slow, peaceful arc at 0.6 kilometers per second. Distant, contemplative perspective. From this altitude, Mars appears as complete world. Polar caps white against red-orange surface, dark highlands contrasting volcanic plains, all visible in single view, planetary beauty, ancient peaceful presence. Tomorrow begins comprehensive orbital survey, mapping potential landing sites, studying surface composition, documenting geological features, planning for eventual descent to surface. But tonight, rest after successful arrival. Sleeping quarters have new view tonight. Not deep space and distant stars, but Mars below, rotating slowly beneath us. Red planet curving away, surface features drifting past. Home for now, orbital perspective. After 259 days of patient travel, exhaustion and satisfaction blend together. The MOI burn worked perfectly, exactly as calculated. We orbit Mars successfully, safe and stable. Arrival achieved. Mars below measures 6,779 kilometers in diameter. Gravity, 3.71 meters per second squared. Surface temperature averaging minus 63 degrees Celsius. Thin atmosphere, ancient world. Every 35 hours, we complete one orbit, periapsis to apoapsis and back. Circling patiently, observing, studying this world. No longer solar orbit, but Mars orbit. Captured by Martian gravity, held gently. Looking at Mars from orbital vantage reveals its history. Ancient river valleys, suggesting liquid water. Massive volcanoes dormant for eons. A world that might once have harbored life. Questions waiting patiently for answers. Tomorrow's work includes detailed imaging of Valles Marineris, polar cap analysis, crater dating studies. Scientific objectives carefully planned. But tonight, crew rests in achieved orbit. Quiet satisfaction, peaceful arrival. The mathematics worked perfectly. 259 days of trajectory, delta V calculations, orbital mechanics. We are exactly where we planned to be. Precision and patience rewarded. After 259 days, we orbit Mars. Mathematics worked perfectly, exactly where planned. Tonight, sleeping quarters have new view. Tonight, sleeping quarters have new view. Tonight, sleeping quarters have new view. Mars below, curving away, red-orange surface with dark ancient highlands. Tomorrow begins orbital survey, planning for landing. Studying world that might have harbored life. Tonight, rest.